Alright, so we're going to solve systems using Cramer's rule, and our first definition is a determinant. A determinant is a square array of numbers or variables enclosed between two parallel vertical bars. In fact, guys, it looks a lot like absolute value bars. That's what they look like. Just two parallel vertical bars. If I told you A, B, B, C, that's what it looks like. Four numbers, or four variables in this case, because there's reason there's four here. They call them, there are four elements. Okay? And it's a 2 by 2 determinant. That's just kind of side information. Okay? When you deal with matrices, this becomes a lot more important. This is kind of a little peak level. Okay. Now, this guy, Cramer, right, he came up with this idea that if you have a determinant like this and you perform this operation on it, it helps you come up with an answer. So what he discovered is if you were going to read this, you start always in the same spot. Like if you were a book, when you stop in the top left corner, that's where you start every time. Like you're going to read a book, top left corner. Okay? Because you'll get confused which way to go with it. So just think to yourself, where would I start in a book? Right here. That's where I'm going to start. So then you take the answer is you multiply those two together. So it's A times C. And the next part I guarantee will stump you because kids forget. Then you have to subtract. Okay, which you think is basic, but it doesn't matter. If your answer is negative, well, okay, you're going to subtract negative. But you have to subtract. So you take the A times B and you subtract, that's important, okay, whatever B times, oh, I wrote B twice. Okay, let's fix the mistake. Okay, you ready? I'm sorry. A, B, okay, and let's use, it doesn't really matter, B, D. Change the C to a D. Oh, that's so smart. Okay. Hang on. I apologize. A, B, C, D. There you go. Fix that for me. I know. Did you fix it? Okay, ready? A, B, C, D. Just what you needed, right? New concept and a teacher myself. Sorry. So A, B, C, D. And then so in blue we multiplied A times what? D. And we are going to subtract B times C. Now that I've butchered that, let's try an example. Find the determinant. You need to know how to find the determinant in order to use Cramer's rule. So I'm showing you how to use the determinant. So there's your bars that I was talking about. And this time we're going to fill it in with 3, -2, a 5, and a 6. Okay? To solve the problem, like I told you, you start like you're going to read a book right here at the 3. And you're going to multiply 3 times 6. Because it's notes, I'm going to show you where we got that. 3 times 6 gave me 18. Alright, that way if we forget later, we can use our notes to learn it. And then what did I tell you? What operation do? We subtract, so minus, okay, whatever answer is here. And in this case, 5 times -2 means I'm going to subtract a -10. 18 minus negative 10 turns to 18
plus
10. Thank you.
Yeah.
Which is 28. Alright, number 2. Negative 2 and 5, and 7 and 8. Where did I tell you to start? Top left corner, right here. So these two numbers, negative 2 times 18, negative 2 times 8, is negative 16. Then subtract the other way. 7 times 5 is 35. Negative 16 minus 35 gives us a negative 51. So you've just found a determinant. In order to solve Cramer's rule, you have to be able to find a determinant. That's how you do it, okay? So it's one side minus the other side. Now let's move on. One more definition, Cramer's rule. Cramer's rule is a method of solving a system of equations that uses determinants. Okay, so here's how you do it, right? They're going to give you a systems of equation. For example, and I'm going to use variables for this one. AX plus BY equals E. CX plus DY equals X. So write this down. They're going to give you something. Okay? We are going to build two sets of determinants out of it. The answer to this is where they intersect, so the answer is the point, right? So the way you do this is we have to find X, okay, and we have to find Y. And to find X and Y, you actually put a division bar, and what Cramer figured out is you put a determinant on top and a determinant on bottom. Okay, and you find the top determinant, you find the bottom determinant, and you divide, and when you get the answer, you get X. Okay. Weird, right? So let me show you how to build the determinants. We're solving for X. In the first column goes whatever coefficients are here. We don't have numbers, we have letters. So what letters are we going to use for the X's? A and C. So they would write AC, AC. For the second column, we need numbers in there. Those come from the Y's. So what variables are here? B, D. Okay, everybody got that? Pretty straightforward, right? Except, if you're solving for X, then this is what he did, okay? He looked at the top determinant, which is this one. And since I'm solving for X, remember this is the X column, this is the Y column. Since I'm solving for X in the top determinant, he said, okay, we're going to switch out the AC with the answers. So this AC becomes EF. And the only reason I'm writing it like this right now is so you can see what I did for your notes. So the AC on the top, we traded out for whatever the answers were, the constants. So AC now becomes EF. Isn't that weird? And then you find the top determinant, and you find the bottom determinant. Okay, let's move to Y. Y is solved the same way. He built a determinant on the top, and a determinant on the bottom. To fill in the determinants. Okay, to fill them in, the first row is x's, so AC, AC, right? And then what goes in the second column? The y's, right? BD, BD. And some of you may have already seen the pattern. But now that I'm solving for y, which one's going to go away? Yeah, you already figured it out. The BD is no longer BD. What are we going to trade them for in the top? EF. So this is now E, and this is now F. That's it. Find the determinant of both, and divide. Okay, so here's an actual problem. Solve with using Cramer's rule. We have to solve for x and y. So let's set up a determinant for x, right? And set up your determinant for y. For x, we're going to use 2, 1, 2, 1. For y, negative 3, 5, negative 3, 5. Okay, but in the numerator, we're not really going to use 2, 1. What are we going to use? 9, negative 2. And guys, I'm just going to do it a couple times like this to see you can see it. Once you've done it once or twice, you're going to know. This actually is 9, and this is negative 2. This is 9, and this is negative 2. So let's find the determinant in the numerator. 9 times 5 is 45, minus whatever you get going the other way. Be careful. Negative 3 times negative 2 is positive 6. So 45 minus 6. Now go to the denominator. 2 times 5 is 10. So you have 10 minus negative 3 times 1 is negative 3. But 2 negatives turn positive, so watch your math there. You get 39 over 13. So x is 39 divided by 13 is 3. You've just found the first half of your answer. Isn't that a weird method? Okay, you just basically use coefficients. It's easy, right? Just completely weird. Okay, now go to y. Let's use Cramer's rule for y now. This time we're solving for y, so all of my x's are going to stay the same. 2, 1, 2, 1. And for my y's, in the top, instead of negative 3, 5, what am I going to put? 9, negative 2, and then my negative 3, 5. Careful, it's negative 3. In your numerator, you're going to have negative 4 minus 9. In your denominator, you're going to have 10 minus negative 3. But guys, in reality, did I need to even find the determinant of the denominator the second time? No, right. You can cross this out if you want, because we already knew the answer was down here is 13. We didn't do that. How come? It doesn't change, does it? The bottom never changes. So once you find the determinant in the bottom, once you're good. So you ended up with negative 13 over 13, so what's y? Negative 1. How can I check my answer to make sure I was right? Yeah, take this and plug it in. Look. Okay, go to the next problem. Number 2. 2x minus 5y equals 2. And 3x plus 4y equals negative 5. Two x minus 5y equals 2, and 3x plus 4y equals negative 5. They set up your determinants. X equals 2, 3, 2, 3, right? But at the top we're going to change it. So 2, negative 5, 2, 3. And negative 5, 4, negative 5, 4. We're going to take 8 minus how much? What's 5? Negative 5 times negative 5. 8 minus 25. Now go the other way. Always start right here like you read a book. Start in this corner. 8 minus negative 15. Be careful, there's minus a negative there. This is a fraction. Negative 17 over 23. Okay, you set up y. I'll give you a second to try it. You set up y. So we're going to solve for y. So all the x's stay the same. 2, 3, 2, 3. The y's are what change. So instead of putting negative 5, 4 here, I'm going to put 2, negative 5, and then my negative 5, 4. Find both determinants. Determine the top and the bottom. Do we already know the determinant in the bottom?
Yeah.
What's the determinant in the bottom? 23. So we don't have to redo that. The bottom determinants will not change. Okay? So in here, you're going to take negative 10 minus, okay, whatever answer you get, which is 6. So negative 16 over 23. So there's your answer.